Welcome to Raw History. Here, we cut through romanticization and speculation to show you, well, the unfiltered reality of human history. Picture yourself standing on the Arctic tundra in winter when temperatures plummet to -40 degrees Celsius and the landscape stretches endlessly without a single tree in sight. For most of human history, survival in such conditions seems impossible without fire and, without wood to burn through those long polar nights. Yet, archaeological evidence from sites across the circumpolar north, from Alaska's North Slope to Siberia's Yamal Peninsula, proves that nomadic peoples not only survived, but thrived for thousands of years in these conditions. The Dorset culture inhabited the Canadian Arctic from roughly 500 BCE to 1500 CE, and the Thule people, ancestors of modern Inuit, spread across the Arctic beginning around 1000 CE, all without reliable access to timber. Excavations at sites like Qilakitsoq in Greenland have revealed occupation layers dating to 2400 BCE, showing continuous habitation in regions where trees never grew. These weren't desperate refugees clinging to survival. These were honestly sophisticated societies with complex technologies, trade networks, and cultural practices that really flourished in Earth's harshest climate. The secret wasn't magic, and it wasn't constant fire. It was in fact a revolution in material science, energy management, and architectural engineering that, well, modern researchers are only beginning to fully appreciate. The Arctic Architect: Indigenous Material Science. The foundation of Arctic survival without wood began with an intimate understanding of animal materials that, honestly, bordered on molecular engineering. Caribou hide became the cornerstone of thermal protection, but not through simple use. Archaeological textile analysis from frozen sites in the Mackenzie Delta has revealed that Arctic peoples distinguished between summer and winter caribou pelts, understanding that winter hides developed hollow core guard hairs that trapped air with exceptional efficiency. These hides were processed through a laborious technique involving scraping, stretching, and, believe it or not, chewing, which broke down fibers and introduced enzymes that made the material supple while maintaining insulation properties. So, women's dental wear patterns from skeletal remains at Utqiagvik, Alaska, dating back to between 500 and 1000 CE, show these distinctive grooves that are, well, really consistent with hide working. This provides us with physical evidence that confirms the practice. Seal skin actually served different but equally critical functions. Unlike caribou hide, seal skin is naturally waterproof and wind-resistant, which is, quite remarkable. Garments that have been excavated from permafrost contexts in Greenland reveal a sophisticated multi-layer construction. There's an inner layer made from bird skin, with the feathers facing inward against the body, a middle layer of caribou hide for insulation, and then an outer shell of seal skin to block wind and moisture. It's really impressive how these layers work together. This isn't guesswork. Actual preserved garments from the Qilakitsoq mummies, discovered in 1972 and dating to approximately 1475 CE, demonstrate this exact layering system. The air trapped between these layers created dead air space, the same principle used in modern insulated clothing, but achieved through purely organic materials requiring no industrial processing. The architectural genius extended beyond personal clothing to shelter construction. The igloo represents perhaps the most elegant solution to Arctic housing, but its sophistication goes far beyond stacking ice blocks. Experimental archaeology conducted by researchers at the University of Alaska Fairbanks back in the 1990s, actually demonstrated that a properly constructed igloo can maintain interior temperatures that are, well, about 15 to 20 degrees Celsius warmer than the outside just from body heat alone. The key, really, lies in snow's crystalline structure. You see, fresh snow is roughly 90% air trapped between ice crystals, and that makes it a truly exceptional insulator. The Inuit understood that the snow had to be just the right consistency, not too powdery and not too icy, which they would test by probing with bone rods before cutting blocks. The domed architecture wasn't arbitrary. It minimizes surface area relative to volume, reducing heat loss, while the curved walls distribute structural stress evenly, allowing construction without internal supports. Fueling the fire within animal-based energy. While these cultures could and did use fire when available, their true innovation lay in alternative heat and light sources derived entirely from animal fat. Marine mammal blubber from seals, walrus, and whales became the primary fuel source across the Arctic. Chemical analysis of residues from ancient lamps shows this wasn't random. Blubber burns cleanly when properly managed, producing minimal smoke compared to wood, which was a critical advantage in enclosed spaces. A single kilogram of seal blubber contains approximately 9,000 calories of energy, making it more energy-dense than most wood species. The technological centerpiece was the qulliq, a crescent-shaped stone lamp that archaeological evidence traces back at least 4,000 years in the Arctic. Examples recovered from pre-Dorset sites dating to 2500 BCE show the design already fully developed, suggesting even earlier origins. The qulliq's shallow basin held rendered seal or whale oil with a wick made from Arctic cotton, moss, or bird, down-arranged along the straight edge. Women tended these lamps with remarkable precision, adjusting wick length and oil supply to control both heat and light output. Ethnographic accounts from the early 20th century, before traditional practices were entirely disrupted, describe expert lamp tenders maintaining steady temperatures for cooking, drying clothes, and warming shelters for days at a time on a single seal's worth of oil. The lamp served multiple functions simultaneously: heat source, cooking surface, light for intricate work during polar darkness, and even a means of melting ice for drinking water. The dietary dimension of Arctic survival really can't be separated from thermal regulation. Analysis of preserved human remains and midden deposits actually reveals diets consisting of, 70 to 90% fat and protein by caloric content. This wasn't preference. It was, in fact, a physiological necessity. Human metabolism generates heat through digestion, and, interestingly, fats provide more than twice the calories per gram compared to carbohydrates while requiring more energy to metabolize, which creates additional warmth. Examination of skeletal remains from the Sadlermiut people who inhabited Southampton Island until, 1902 to 1903 shows bone chemistry consistent with almost exclusive marine mammal consumption. Their bodies basically became adapted furnaces, generating internal heat through constant high-fat processing. Shelter and mobility, really shaped a life on the move. The nomadic aspect of Arctic life wasn't a disadvantage. It was, in fact, strategic brilliance. Following caribou migrations and seal hunting seasons required shelter solutions that, balanced thermal efficiency with portability. The traditional qulliq, or skin tent, used frames of driftwood or whalebone covered with caribou or seal skins. Archaeological evidence from abandoned campsites across the Canadian Arctic shows these structures left minimal traces precisely because they were designed for rapid assembly and complete removal. Studies of historical Inuit camping patterns reveal sophisticated understanding of microclimates. Camps positioned on south-facing slopes for maximum solar gain during brief daylight hours, behind natural windbreaks formed by ice formations or terrain features, and near reliable ice conditions for seal hunting. Winter and summer, required quite different approaches. Winter structures really emphasized insulation and heat retention, while summer dwellings prioritized ventilation to manage, surprisingly intense solar radiation and even insect pressure. This kind of flexibility actually demonstrates not a rigid adherence to single solutions, but rather an adaptive problem-solving approach, carefully calibrated to meet seasonal demands. These Arctic survival systems, honestly, offer profound insights for contemporary challenges. Every element of nomadic Arctic life was sustainable by necessity, nothing wasted, and, everything repurposed. Seal provided food, fuel, clothing, shelter covering, waterproof containers, and tools. Caribou supplied food, hides for clothing and bedding, sinew for thread, antlers for tools, and bone for implements. This wasn't, romantic harmony with nature. It was actually pragmatic resource management where, quite frankly, failure meant death. The real lesson here isn't about returning to pre-industrial lifestyles. It's about recognizing that, human ingenuity often achieves remarkable results through deep environmental knowledge and material understanding rather than energy-intensive technology. Modern emergency preparedness, extreme environment engineering, and sustainable design all, in fact, draw inspiration from these ancient solutions proven over, millennia of continuous use. If this exploration of evidence-based Arctic survival has shown you a different side of human adaptation, then, hey, subscribe to Raw History for more deep dives into unfiltered historical reality. Share this with anyone who believes modern technology holds all the answers. Sometimes the most sophisticated solutions are the ones that worked for thousands of years without requiring any fuel but human knowledge.